Hi everyone, we're just continuing what we did in the previous video. You should already know what independent and dependent means, so we don't need to talk about that anymore. And we're just going to talk about some things about in any order and when we're talking about in that order, with replacement, without replacement. So we have, this is similar to the ones we did before. We're selecting 3 coins at random. We have 3 nickels, 2 dimes, and 5 quarters, so that's 10 total. And we want to find the probability of selecting 1 nickel, which is 3 out of 10. We're not replacing. This is going to be dependent then. 1 dime, so that's going to be 2 out of 9. And then 1 quarter, so that's going to be 5 out of 8. In that specific order. All right, so when you multiply that out, you get 1 over 24. Now, the next one is, we're doing the same thing, but it's with replacement. So this is just the same problem, but this is independent. So my denominators stay the same, and I'm going to keep them the same. And in this case, we get, with replacement, we get 3 over 100. You get to get the approximate value with the calculator. Okay, now we're going to talk about when it talks about in any order. So basically, we already know what with replacement would be. So if I go back, with replacement is 3 over 100. So we already did this. This is 3 over 10 times, we already know it's 3 over 100. So I have to go back and look. It's 3 over 10, 2 over 10, and 5. So this would be 325. 3 over 10 times 2 over 10 times 5 over 10. So we got 3 over 100. But they're talking about in any order. And this is where we go back to permutations. That's why it's important that we went over permutations before we did this. In any order would mean that I could get, and I'm going to write them down, nickel, dime, quarter. I could get nickel, quarter, dime. Then I could get dime, quarter, nickel. And then I could get dime, nickel, quarter. And then I could start with quarter. I could get quarter, dime, nickel. And then quarter, nickel, dime. So if I do any order, I have to multiply this by 6. So when they talk about any order, what you're really talking about is 3 factorial. Since there's 3, we have 3 here. So all you need to do, especially if it gets bigger, you don't want to write all this out. If it talks about any order, you're going to use 3 factorial, which we recall as 3 times 2 times 1. So we're going to do the same thing with this problem. The one without replacement was 1 over 24. So I'm just going to use that and multiply that by 3 factorial. And when you do that, that's going to be 6 over 24, which is 1/4. This one was in any order with replacement. This was 9 over 50. And those are your 2 answers there. So a little more complicated. You have to be careful with the wording on any order versus in the exact order. And just remember that when you're talking about in any order, you're talking about all the possible combinations. Okay? Now, this one's about dice. So we have yellow, red, and green dice. And what's the probability that all 3 dice show a 4? So basically, we're going to take, these are all independent, by the way. So the possibility that the red shows a 4 is 1/6. The possibility that a green shows a die is 1/6. Remember, die has 6 faces. And the yellow shows a 4 is 1/6. So that's going to be 1 over 216. Whoops, why did I write 12? All right. Now, none of the dice show a 4. So this is like not this one. And if you want, you could just do 1 minus 1 over 2/16. All right. Or you could just say, well, not to show the 4, that would be 5 over 6 times 5 over 6 times 5 over 6, which equals 125 over 2/16. Okay? So if you did this one here, you would just do 2/16 over 2/16, because that equals 1 minus 1 over 2/16. And that gives you the 125 over 16. All right. The red die shows an even number. So if a red die shows the even number, that would be 3. There's 3 out of 6, because half of the die is even, half of it's odd. The other 2 die show different odd numbers. So when you roll either the green or the yellow, the green one shows an odd. So that would be 3 over 16 again. But the other die has to show a different one, so that would be 2 over 6. These are all independent because the dice are independent. So when you get this, you're going to get 1 over 12. Now this one, the last one's a little tricky. All 3 dice show the same number. So if they all show the same number, we don't know what number it is. So we're going to have 3 slots. We're using our counting principle. The first die could be anything, so it could be any of the numbers, 6 out of 6. However, the other 2 die has to be what this first one was, so that would be 1 over 6. And the next one has to be the same number. So our answer would be 1 over 36. And in some of these, we're going pretty fast. You need to think about them, especially if you haven't done probability in a while. Okay, we have the last problem. Make sure you have a deck of cards and you know what they look like. There's 52 cards, and you need to know half the cards are black, half are red. There's 13 in each suit. There's 4 suits, and the suits are hearts, spades, clubs, and diamonds. So there's 13 each. 13 times 4 is 52. All right. Oops, sorry. And diamonds. So I'll just put diamonds like that. So we want to select 2 black cards without replacement. So this one's pretty easy. Out of the 52 cards, half of them are black. So that's 26 out of 52. Now we don't put the one we drew back in, so we get 25 are left. And it's 51. Remember, without replacement is dependent, and our common denominator changes. So the answer here is 25 over 102. And if we do the same thing, but with replacement, the denominators stay the same. So does our numerators. So you just multiply this. And when you multiply that across, you get 1/4 is 1/2 times 1/2, basically. All right? 1 red card and 1 spade in any order. And then 1 red card and 1 spade in that order. So let's do 4 first. Remember, we're going to have to do the permutation thing there. So basically, 1 red card and 1 spade. 1 red card would be 26 out of 52. We don't put the cards back in. It's without replacement. So that's going to be over 51 something. And how many spades? The spades are not red, so that part is independent. And there's 13 spades. Then we multiply that across. You get 13 over 102. Now, when they talk about in any order, basically you're going to multiply this by 2 factorial. Or you can think of it a different way. The 1 red card and 1 spade we already did, which is this part. Or, and we're going to get into or in the next video, or means to add. So, and means to multiply in probability. We could have got the spade first, which would be 13 over 52, times, and then we have 26 over 51. These two amounts are the same. They're both 13 over 102. So all you have to do is multiply this by 2. So I'm going to put this down in this area. So it's just basically 2 factorial, which is just 2, over 13 over 102. And that would equal 13 over 51. Okay? All right. In any order, it's easier to get, this probability is better than this one. So in any order, the probability is better. Okay, the next video is going to be adding probabilities. They're a little more complicated. They're the hardest part of probabilities. So good luck, and I hope you all have a nice day. Bye-bye.